Ocean currents, Pacific Ocean currents. So, very good, very informative once you figure out how to play with it. Site is earth.nullschool.net, and you can turn on layers and views and see different aspects of the Earth's environment in near real time. They're based on models. They're based on huge information sets about different aspects of the atmosphere and ocean surfaces that we know. And even a little bit below the surfaces we know, because remember, some radars can see through the ground now. We've gotten that good with it. Instead of having to put thumpers out there, we can use something different to try to look into the Earth. So we live, we learn. Oceans, ocean currents, ocean flows. So that's why I brought up earth.nullschool.net. If you go to the ocean layers, you can find temperatures and temperatures over time and how they change. You can see how it moves through the oceans. Paul Beckwith is pretty good about using that site, and a few other people. And if you go to the site, you can go to the About and go find the source code and a lot of information about where the data sets they are getting comes from. And so there's a hosting service behind that. It's a piece of art, a fine piece of art based on reality. So earth.nullschool.net, very good one. There you can look at and see what we know and what we understand about primarily atmospheric transport. Okay, you can see if you turn on, say, the sulfur content, you can see that the atmosphere carries sulfur around. You can see that the atmosphere carries dust and dirt, particulate matters. So on that site, I think you will see the PM 2.5 and PM10 and PM25. See, those are selected kind of based on what you're looking for. And you can get some real-time readings now, which just wasn't able to do before. Before you had to do long time-based samples. Now you can do shorter time-based samples. So, sampling techniques for different types of samples. So, transport picture, earth.nullschool.net gives you a very good idea of what gets moved around in the atmosphere. One of the things this helped me, and I went looking for more science regarding it afterwards, but while in Sweden, it was mentioned how much dust, how colored the air is, how you can't see very far. And they actually will close airports and such. They don't want aircraft flying through these sandstorms. So they have to know about them just to keep their airplanes running longer, not have to replace an engine for abrasion issues. So a lot of folks looking at these details and changing flight paths. They're changing flight paths because of upper atmospheric currents. They're changing flight paths to save money because they can take advantage of the jet stream or avoid the jet stream. Find a reverse jet stream maybe. If it's a far enough flight, you fly south of the equator instead of north. I don't know, but someone does. So the oceans. When you see the ocean, you're seeing a reflection of the sky. Those things that happen in the sky, those clouds, those many different named clouds, have reasons for their formation, where they are at altitudes and atmospheres and temperatures and barometric pressures. So very large, let's call it semi-closed system is the atmosphere. The ocean is truly no different. the ocean is slower than the air and the wind. So its movements are a little longer over time in the way some of these things would happen, because you're talking, maybe a few miles per hour ocean currents, 17 knots. I'm not an oceaner, I'm not an oceanist. So different type of transport system in the oceans than in the atmospheres, but still highly related. What goes on up there goes on down in the oceans, because the ocean is dealing in atmosphere is dealing in lower pressures than we experience at sea level. Under the ocean is higher pressures because of the tons of water. Water is 8-9 pounds a gallon. So you're carrying around that 8 or 9 pound gallon of milk, and it's not sold to you in pounds, is it though? It's sold to you in volume. So, science, general thing, it's not really there, it's hidden. So that water has mass. The deeper you go, the more pressure that mass puts on you, and the more buoyancy is being applied, which in this case would be a counterbalance to either crush you and make you a lot tinier than you are, or to force you to the surface. So these are the pieces that begin to make up the ocean. If you look too close. So back to a nuclear disaster. From TEPCO Japan and General Electric America. The atmospheric releases become deposition somewhere. This deposition can be measured, and we now can know where dust and sand and soot comes from, to a very high degree of confidence. Not absolute, high degree of confidence you could take to a court. So I just checked the time and threw myself off. So it's 8 minutes now almost. So these balances, these nuances in how the clouds are formed, how the jet stream has been up there longer than we've been down here, and it still doesn't seem to know what it's doing, but it does in this, long, slow dance of planetary evolution. So when you look at the ocean, you have to kind of think in those, even if you're a fisherman, you're thinking that. And you know that the bluefish are down this far, and you know that the tuna are probably behind the bluefish and not in front of them, because tuna will eat anything. And there might be pods of blue whales going by another 3 months out in their travels. So that travel through time effect is consistent, even though the paths change. So the oceans are flowing like this. They do these long, slow, nonchalant separations and depositions and thermal transfers. And there's a volcano on the bottom of the ocean floor that's more active than anything on the surface. And the ocean absorbs that. And we might see some of the plumes. We might see an island pop up. So inside that Pacific Ocean is a whole bunch of, what else can you call it but waves, right? And they change directions. So as they do that, as these accumulations happen, these are kind of mechanical now, right? We're talking about waves and things leaching out of soils and getting washed out of soils and falling out of the air and then stopping. But the soil leaching is a lot slower and more consistent, maybe. Depends on the tides and the weather and if another storm comes by. So there are a lot of variables, but you can go, soft measurements, subtle measurements over time and see where the changes are spreading out. This is the value of some of the equations I talked to, or understanding how mapping is done if you don't use equations. Or you can use mapping to begin and equations to better define and defend. And so, yes, the elements, and most of them by now are molecules. They have bound with something else, even with themselves. Just like oxygen by itself is an O2. You won't find O by itself. O will find something to get with. And since O only does O without blowing up or oh, never mind. All right. So in these water layers, these things can and do settle to the bottom. So now they're condensates. They are dust in the ocean. They're mud. They're what the squirmy things squirm in, and the bottom feeders bottom feed. If they're contained in one of the stratas or layers of the ocean waters, remember these are driven by flows and temperatures, sunlight and cold, and the occasional earthquake that moves the mountains. So those things are still happening. Those separations, the sediments are still happening. Those become a part of the food chains, depending on where those chemicals, those compounds, those elements are. And the food chain begins digesting them. And the biological half-life has begun. Before we just had an environmental half-life, right? Where is it going to go? Where is it going to settle? Now we've introduced a biological system, because that phytoplankton is going to use cesium, maybe, depending on how it's structured. Inside is a compound, because elements, isotopes, like to bind to things in many different ways until they find something better. They're just cheap. They're easy. So that accumulation into the food chain means that all those almost microscope size, they are microscope size, all the creatures, every layer of whatever has gone through that has been introduced to either elements that are nasty or isotopes that are more nasty. Leads, mercuries, plutonium, cesium, uranium, the isotopes, again, 140, 180 isotopes came out of the Fukushima site. So those little things eat them, and then the bigger things eat them, like whales, like other, the small food feeders. And when those die, they fall to the bottom, and something else down there eats them. So the biological accumulation of these things happens. The best one to follow is pelagic fish. Those are fish that basically swim oceans. They're not local to an area or even a continent. They swim oceans. So that's most of your big tunas, whales, dolphins, porpoises. Those are all, I think, in that pelagic fish family. And so these things feed across the continent, and they follow these flows and these ebbs and tides of long nature cycles in those currents and temperatures in the oceans to feed. So those millions of krill that a larger animal fed on, and then it accumulated, it absorbed those into its bones over maybe years before it gets eaten by something bigger. Now that something bigger has accumulated, has just digested 5 years of biological uptake of heavy metals and elements. The next big fish comes along. So there's that food chain continuing, even if it's off Asia, even if it's off California. No matter where this is going on, there's local species and then these larger species that come through and harvest the local species on their way elsewhere. That's the cycles of ocean life, right? And remember Jacques Cousteau? Who remembers Jacques Cousteau? What an inspiration back in that day, right? Go into space, Jacques Cousteau underwater, and somehow we got too smart and education was pulled from under our feet. So those times are fading in history. The knowledge isn't. It's in universities. It's being taught. It's being invasively taught. And some of the universities that are taking grant money and these charitable donations are maybe misguiding some people. Hard to tell, isn't it? Maybe their taxes-free stuff shouldn't be tax-free, eh? So these are the big sciences that we do, and it might be Battelle under some type of contract to the federal government or some other large institution is going to fund 3 boats to go out for 6 months for 5 years, and they're a piece of funding, and there's more found from across wherever because some other people get this, do it for a living. But it was just 3 boats. It wasn't 5. It wasn't an invading army. It wasn't a tactical response. It was more of a, well, we know what's going to happen. Let's just go out and measure how bad it is. So there's a different view, different perspective, different frames on the same picture maybe. Different paradigm. So pelagic fish. These are the big guys. These are the kings of the ocean. These are the best tunas in the cans. That's how it is, right? These folks are eating the biological uptake pathways for possibly harmful elements that we've put in the water, and because of their feeding habits, they're accumulating these in like mass doses. Instead of every meal being a meal like it was for the krill, every meal is a dose. You've changed the dynamics of the impact to that other species. And when we follow that pathway up through the food chain and our ancestors, we're vulnerable to these same things. And man, Lord knows I love tuna fish. But in tuna fish, one of the cautions in tuna fish is mercury, right? Lead and mercury. Most of the lead and mercury is from power plants. The other piece of the lead and mercury is from nuclear decay products. So the ratios of all of those things have meaning to people that have the supercomputers and the algorithms in their heads to plug in to be able to make sense of it. So that's 20 minutes short about ocean flows and temperatures. To be continued.